We're now looking for the solution of exercise 1d of the first tutorial. So one wants to solve psi sub t plus t square psi x plus x psi equals 0. First, in the case where the initial conditions are such that at t equals 0 for any x, psi of x0 is given by f of x. And then, in a second time, we look for a solution only defined for x positive and t positive such that psi of x0 is f, but this is only for positive x, and psi of 0t, only for positive t, is equal to g of t. But let's solve the first, in the first case there. So one use the method of characteristics, and let's introduce psi t, which is phi of xt and t, where x of t is yet undetermined. We will choose the most appropriate, we make the most appropriate choice. So if one does d psi, if one computes d psi dt, this is psi t plus dx dt times psi x. And when comparing with this expression, one sees that it seems appropriate to choose dx dt equals t squared. In this case, one has d psi dt equals, look above here, minus x psi. So first, let's determine the characteristics. Well, they correspond to this equation. So of course, characteristic curve, it's of the type x of t equals 1/3 t cubed plus constant, right? And in the case of interest for us, something like that. In the xt plane, these are curves of this type, and they would go like that for negative t, but we don't have negative t. And otherwise, it's something like that. And okay, and for instance, if I take a given here, x and t, the characteristic that reaches x and t is issued from x bar, which is given by x bar equals x minus t to the cube divided by minus t cubed divided by 3. Okay, and then one needs to solve this equation, which is dx dt equals minus x, x is here, so it's minus 1/3 t cubed minus x bar psi. Okay, so this reads d phi divided by phi equals minus x bar minus 1/3 t cubed dt, and this has to be integrated from t equals 0 there, where phi is phi of x bar, to there. So this leads to ln of phi minus ln phi 0 at t equals 0 equals primitive, oops, sorry, there was a mistake here, primitive of that, which is minus x bar t plus t4 divided by 12 from 0 and t. And it's easy. So this shows that thus now one goes back to phi. It shows that phi of xt equals this guy, which was initial, which is here, f. Let me check if one sees the screen, yeah, f. So it's f of t times exponential minus x bar t minus t4 divided by 12. Okay, and but here, oh, sorry, it's not f of t, it's f of x bar, initial value. And where x bar is given by this expression. So that means that phi of xt equals f of x minus t3 divided by 3 exponential. So let me think. One will have, well, let's do it slowly. Minus x minus t cubed divided by 3 minus nt minus t4 divided by 12. And this guy here is simply minus xt 1/3 minus 1/12 should be plus t4 divided by 4. And one can check, I will not, but check, do the check yourself, that indeed psi t, what is the equation? Plus t square psi x plus x psi for 0. It's easy, do it. And I can do another simple check, is indeed that psi of x 0, that is easy. It's f of x, of course. Okay, so this is it for the first case. Now let's go to the other case where the boundary conditions are determined not on the axis of abscissa, but also on the axis of ordinates. So one has something like that. Again, let me plot the characteristics. They still are the same. So one has something like that, something like that, something like that, something like that. Okay. But the point is, in this region there, everything is as previously. The point is, in this region, so this characteristic is the one where one has x equals t cubed over 3, this one. And one is, when one is in this region there, the one which is hatched in green, in this region, things are different because the boundary conditions say are fixed here for a given t bar, for instance. And so the green region is a new the green dashed region is the region where x is in between 0 and t cubed divided by 3. Here, one has to change, still one uses the method of characteristics, but one changes the boundary condition. They are fixed on the vertical t-axis, okay? So for instance, the equation of the characteristics is written as x equal 1/3 t cubed minus t bar cubed. And indeed, when t equals t bar, one is here, x equals 0. Okay, and one still has d psi dt equals minus x psi, which is now written as 1/3 minus x, so it's t bar cube minus t cube psi. And this has to be integrated starting from there. So this is ln psi minus ln psi of t bar equals primitive of this guy, which is 1/3 t bar cube t minus t4 divided by 4. And here, beware, one starts at t bar. Okay? And this guy, this is, I think it's minus 1/4 of t bar 4 plus 1/3 t bar 3t minus t4 divided by 12. You can check that, but it's easy. So it means that one has the solution in this region, only in this region there, psi of xt is equal as at g of t bar, which is the initial condition here, exponential of this guy. Okay. And again, so when one is here, let me check. Yeah, when one is here somewhere at xt, the boundary conditions are fixed by the initial t bar, where t bar is there. So t bar is simply t bar from there, it's t cubed minus 3x power 1/3. And this guy is positive because one is in this region. That's it. So it means that psi of x and t is equal to g of be the ugly minus 3x 1/3 exponent of minus, so t bar, it's t3 minus 3x for half divided by 4 plus 1/3 t bar cube. It's simply t cube minus 3x times t minus t4 divided by 12. Okay. And that's it. And that's it. And this is, I mean, all this equation is for 0x, because if x is larger than t cubed divided by 3, when it's here in the red area, and the previous treatment applies. So one could indeed also here check that this guy is a solution of the PDE we are considering. It's a bit ugly, but I've done it. It's in the handwritten corrections, and it works. So this is the end of the solution of this exercise.